Okay, here's my low EMF workstation. There's a keyboard and trackball. They're analog, no processor. And then over here, there's the analog interface and the processor board and the shielded enclosures, which are now opened up so that you can see inside. There they are. There they are. Okay, whoops. I went too far. Okay. So, this is the analog interface. This is the processor. This is the original processor from the Keytronic infrared keyboard with trackball. That's the trackball board, the processor board, and the original shortened cable between them. This is just a power filter. This used to drive infrared, now it drives fiber optics. The analog interface, I'll go into that when we do a close-up and tell you what all the little bits are. Okay, so these are pi filters, pi filtered connectors, a DB25 and I think this is a DB9. This is the keyboard, this is the trackball. The keyboard has 1 mega ohm pull ups for rows and 1 mega ohm pull downs for columns. There's 8 rows and 16 columns. And the normal keyboard, the 8 rows are actively strobed and the columns are then read to see where the intersection is between rows and columns. In this case, this is a row of analog comparator chips and they are monitoring each channel here is monitoring. There's 3 separate ones for control, shift, and alt. They aren't part of the matrix. They've been brought in as separate signals. The rest of the matrix, the analog comparator is set to see the signal going to the in-between state. If it was pulled high, it sees it going lower. If it was pulled low, it sees it going higher. And that turns on that signal, which then goes here to the opto-isolator. The opto-isolators have the outputs bussed together so that when it turns on, say row 3 turns on, it turns on the row 3 opto transistor. And the column 7, let's say, turns on, it turns on the column transistor. When that happens, the processor is strobing, it's still doing the normal active strobe. It thinks it's still connected to the keyboard. But in fact, the keyboard is being simulated by the bust transistors of these opto-isolators. So they are closing the switch. So the strobing is happening right through here. You see the copper tape here, besides being grounded to the case, it's also wrapped around the other side so that all those wires are shielded. So we don't have quite so much radiation affecting the rest of the sensitive analog circuitry. We're not concerned about that, we're concerned about it getting onto these cables and getting back to the keyboard or the trackball, which we want to keep as clean as we can. The pi filters that we're using, a pi filter is a capacitor, an inductor, and a capacitor, a CLC type of passive filter. These are pretty spendy. This is about at least $120 just for the DB25 connector. And I tend to do things a little bit differently now to save some money, but nonetheless, this was one of those I desperately need a computer and I cannot fail projects. So now I'll go over and show you the other board. Okay, so here's the standard processor module from this discontinued Keytronics product. They pulled it off the market within 90 days of its introduction because of software bugs, alas. Anyway, I've modified it to put a fiber optic emitter on it, reduce the drive signal a little bit, but it's still capable of driving over 200 feet. This is the original trackball. It had a tiny little thumb ball, a small ball, but the signals are exactly the same, they're compatible, so I'm able to bring the reconstructed photodetector signals from the mechanical trackball, the CH Products Pro trackball, and substitute those for the original small mechanical trackball here, and it works just fine. This is just a passive filter for the 6-volt DC coming in here. Okay.